If f of x is cos x, find f dash of pi by 4 by first principle. The options are 1 by root 2, minus 1 by root 2, root 2 and minus root 3 by 2. So by first principle, f dash of x is 1 by h, limit h tends to 0, f of x plus h minus f of x. So we substitute the values. F of x is cos x, so this is 1 by h cos of x plus h minus cos x. Now this is in the form of cos of a minus cos b. So this can be written as limit h tends to 0, limit h tends to 0 minus 2 times sine of x plus h by 2 into sine of h by 2 divided by h. Now we divide and multiply by 2, so we get limit h tends to 0 minus 2 times sine of x plus h by 2 into sine of h by 2 divided by h by 2 into 2. Now limit h tends to 0 sine h by 2 by h by 2 is 1. So this is minus 2, and we substitute the value of the limit. We put the limit, so we get h equals 0. So we finally get sine of x plus 0 into plus 0 into 1 divided by 2. 2 gets cancelled. We are left with f dash of x is minus sine x. So x is pi by 4. So we get f dash of pi by 4 is minus sine pi by 4, which is equal to minus 1 by root 2. Answer is B, minus 1 by root 2. The derivative of f of x is equal to 1 by x from the first principle is, now we again use the first principle, which is f of x, f dash of x is 1 by h, limit h tends to 0, f of x plus h minus f of x. Again we substitute the values, we get 1 by h, limit h tends to 0, f of x is 1 by x, so this is f of x plus h is 1 by x plus h minus 1 by x. We cross multiply the terms, we get 1 by h, limit h tends to 0, x minus h upon x plus h plus x plus h into x, that is equal to x gets cancelled. We are left with limit h tends to 0, 1 by h into minus h upon x plus h into x. H gets cancelled and we put the limits, we get 1 upon minus 1 upon x plus h is 0, so x plus 0 into x, that is equal to minus 1 upon x square, which is option B. The derivative of f of x equals root of x plus 2 is by using the first principle, and these are the options. So we use the first principle, we get f dash of x is limit h tends to 0, f of x is root of x plus 2, so f of x plus h is root of x plus 2 plus h minus f of x, that is root of x plus 2 divided by h. We multiply and divide the numerator and the denominator with its conjugate. We get limit h tends to 0. The conjugate is root of x plus 2 plus h plus root of x plus 2 divided by root of x plus 2 plus h plus root of x plus 2 into root of x plus 2 plus h minus root of x plus 2 divided by h. This is in the form of a plus b, a minus b. So we get limit h tends to 0. So this is x plus h plus 2 root of x plus h plus 2 the whole square minus x plus 2 root of x plus 2 the whole square divided by h into root of x plus 2 plus h plus root of x plus 2. This can be simplified as x plus h plus 2 minus of x plus 2 divided by h into root of x plus 2 plus h plus root of x plus 2. Limit h tends to 0. Now we put the limits, we get x plus 0 plus 2 minus x plus 2 into we don't put the limits, h tends to 0. This term gets cancelled, x minus x, 2 minus 2, and this term remains the same, root of x plus 2 plus h plus root of x plus 2. We are left with limit h tends to 0, h upon h into root of x plus 2 plus h plus root of x plus 2. H gets cancelled, and now we put the limits, we get h equals 0, so this is root of x plus 2 plus root of x plus 2. This is equal to 1 by 2 times root of x plus 2, which is equal to, which is option C. Y is equal to 7x raised to 5 minus x raised to 4 plus 4 times x raised to 3 by 2 plus 8 by root x minus 4 sec x. We have to differentiate it with respect to x, and these are the options. So dy by dx is differentiation of 7x raised to 5 is 7 times 5 into x raised to 5 minus 1, that is 4, minus 4 times 3 by 2 x raised to 3 by 2 minus 1, which is x raised to half, plus dy by dx, d by dx of 8 into, this can be written as x raised to minus half, minus 4 times differentiation of sec x is sec x tan x. We simplify it further, we get dy by dx is equal to 35 x raised to 4 minus 6 x raised to half plus differentiation of x raised to minus half is 8 times minus half into x raised to minus 3 by 2 minus 4 times sec x tan x. This gets cancelled, we are left with 35 x raised to 4 minus 6 x raised to half minus 4 x raised to minus 3 by 2 minus 4 sec x tan x. We simplify it according to the options, we get 35 x raised to 4, which is option D or B, minus 6 x raised to half. There's a correction here, we missed the term minus x raised to 4 and this is plus, so we differentiate it, we get minus 4 into x cube, and we make the correction everywhere, minus 4x cube. So this is 35 x raised to 4 minus 4x cube minus, this is plus everywhere, so this is plus 6 times x raised to half minus x raised to minus 3 by 2 can be written as 4 by x root x minus 4 sec x tan x. So we compare B and C with the answer. We have 35 x raised to 4 minus 4x cube plus 6x square, x raised to half minus 4 by x root x minus sec x tan x. So the option is D. The 35 x raised to 4 minus 4x cube plus 6x raised to half minus 4 by x root x minus 4 sec x tan x. We have to differentiate y is equal to sin x upon 1 minus cos x with respect to x. So we use the formula differentiation of u by v. We get dy by dx is v derivative of u, that is v in this case is u is sin x and v is 1 minus cos x. So v differentiation of u, that is 1 minus cos x into derivative of sin x minus u into derivative of v, that is sin x into derivative of 1 minus cos x divided by v square, that is 1 minus cos x the whole square. We simplify it, we get 1 minus cos x, differentiation of sin x is cos x, minus sin x into differentiation of 1 minus cos x is sin x, and 1 is 0, so this is sin x, divided by 1 minus cos x the whole square. Expanding the brackets, we get cos x minus cos square x minus sin square x upon 1 minus cos x the whole square, that is cos x minus cos square x minus sin square x, cos square x plus sin square x upon 1 minus cos x the whole square. This is 1, so we get cos x minus 1 upon 1 minus cos x the whole square. We take minus 1 common, we get minus of 1 minus cos x upon 1 minus cos x the whole square. The term gets cancelled, we are left with minus 1 upon 1 minus cos x, that is option B. We have to differentiate y is equal to 1 plus x square upon 2x plus 1 with respect to x. These are the options. So again we use the formula differentiation of u by v. So dy by dx is, u in this case is 1 plus x square and v is 2x plus 1. So v derivative of u, that is dy by dx of x square, which gives 2x. Differentiation of 1 is 0 and for this is 2 into x, minus u into derivative of v. Derivative of 2x plus 1 is, for 2x it is 2 and 1 it is 0, so into 2 divided by v square, that is 2x plus 1 the whole square. Expanding the brackets, we get 2x plus 1, we take 2 common in this term, we get 2 times 2x plus 1 into x minus 1 plus x square divided by 2x plus 1 the whole square. We simplify it, we get 2x square plus x minus 1 minus x square divided by 2x plus 1 the whole square. This leaves us with 2 into x square plus x minus 1 divided by 2x plus 1 the whole square, which is option B. D by dx, differentiation of 1 by x raised to 4 into sec x is, these are the options. Sec x can be written as 1 by cos x, so we can write this term as, let this be y, so dy by dx is equal to cos x upon x raised to 4. So now this is in the form of u by v, so this can be written as differentiation of u by v, which is v into derivative of u, that is x raised to 4, derivative of cos x, that is minus sin x, minus u into derivative of v, that is cos x, into derivative of x raised to 4 is 4 times x cube divided by x raised to 4 square, that is v square. That we get minus x raised to 4 sin x minus cos x times 4x cube divided by x raised to 8. We take x cube common, we get x cube 4 cos x minus x sin x divided by x raised to 8. So x raised to 3 gets cancelled, we are left with 1 by x raised to 5, 4 cos x minus x sin x, which is option C. If y is log of cos x to the base 10, this is base, this is the base of the log. So if y is a log of cos x to the base sin x, then dy by dx is, these are the options. So first we have y equals log of cos x to the base sin x. By rule of logarithms, we can write this as log of cos x upon log of sin x. So now we differentiate it, we get dy by dx is, this is in the form of u by v. So v into derivative of u, that is derivative of log of cos x is 1 by cos x into derivative of cos x, that is minus sin x, minus u into derivative of v, u into derivative of v, that is log of cos x into derivative of sin x, that is 1 by sin x into derivative of sin x, which is cos x, divided by v square, that is log of sin x the whole square. Sin x upon cos x is tan x. So we have log of minus sin x into log of sin x into tan x minus log of, this is into minus, so minus log of cos x into cot x. Taking minus common, minus 1 common, we get log of tan x times tan x into log of, this is divided by log of sin x the whole square. So the final answer is minus tan x times log of sin x minus cot x times log of cos x plus divided by log of sin x the whole square, which is option B. Y is equal to x raised to 4 tan x minus x cube sec x. So we have to differentiate y with respect to x, and these are the options. So first we rewrite the expression for y. Y is equal to x raised to 4 tan x minus x cube sec x. Now this is in the form of u into v, differentiation of u into v. So we are using it twice for this term as well as this term. So we get dy by dx is u into v. So u into derivative of v, derivative of tan x is sec square x plus v into derivative of u, that is tan x into derivative of x raised to 4 is 4x cube, minus we use it again for second term, we get x cube, derivative of sec x is sec x tan x plus v derivative of u, that is 3 times x square. We rearrange the terms according to the options given. We get x raised to 4 sec square x plus 4x cube tan x minus x cube sec x tan x minus 3x square sec x. So we find the options here. So x raised to 4 sec square x, so this can be either a or c, plus 4x cube tan x. So this is the only option which has plus 4x cube tan x, so this is the answer. So the answer is x raised to 4 sec square x plus 4x cube tan x minus x cube sec x tan x minus 3x square sec x. We have to differentiate y is equal to 1 plus 2x plus x square divided by 1 minus x square with respect to x. These are the options. So first we simplify the numerator. Y is 1 plus 2x plus x square plus 1 minus x square. This is in the form of a square plus 2ab plus b square. So we can rewrite this as 1 square plus 2 times x into 1 plus x square divided by 1 minus x square. So this is 1 plus x the whole square, and we can rewrite this as 1 plus x into 1 minus x. 1 plus x gets cancelled. We are left with 1 plus x upon 1 minus x. Differentiating this with respect to x, we get dy by dx. This is in the form of u into u by v. So this is v into derivative of u. Derivative of u is 1. Since derivative of x is 1, minus u into derivative of v. Derivative of v is minus 1 divided by v square, that is 1 minus x the whole square. So dy by dx is 1 minus x minus 1 plus x minus 1 divided by 1 minus x the whole square. Dy by dx is 1 minus x minus 1. 1 gets cancelled. So 1 minus x, this is multiplication. So 1 minus x in the bracket minus 1 minus x divided by 1 minus x the whole square. Expanding the term, we get 1 minus x plus 1 plus 1 plus x plus 1 divided by 1 minus x the whole square. So x gets cancelled. We are left with 2 upon 1 minus x the whole square, that is 2 times 1 minus x raised to minus 2, which is option C, 2 into 1 minus x raised to minus 2. Y is equal to x raised to a by x raised to b the whole raised to a plus b, x raised to b by x raised to c the whole raised to b plus c, x raised to c by x raised to a into whole raised to c plus a. So we have to find the derivative of y with respect to x. The options are 0, 1, a plus b plus c and 2. First we simplify the expression of y. So x raised to a by x raised to b raised to a plus b, x raised to b by x raised to c raised to b plus c into x raised to c by x raised to a raised to c plus a. By law of indices, we can write this as x raised to a minus b raised to a plus b. Similarly, x raised to b minus c raised to b plus c and x raised to c minus a raised to c plus a. That is, again by law of indices, we can write this as x raised to a minus b into a plus b into x raised to b minus c into b plus c into x raised to c minus a into c plus a. So these are in the form of a plus b, a minus b. So we can write this as x raised to a square minus b square into x raised to b square minus c square into x raised to c square minus a square. Again by law of indices, we get x raised to a square minus b square plus b square minus c square plus c square minus a square. That is equal to x raised to 0, which is anything raised to 0 is 1. So y is 1. So differentiation of y with respect to x is differentiation of 1, that is 0. So the answer is A, 0. If y is equal to 1 plus x square by 2 factorial plus x cube plus 3 factorial, so on and so forth till x raised to n by n factorial, then dy by dx is, the options are y plus x raised to n by n factorial, y minus x raised to n by n factorial, y minus 1 minus x raised to n factorial. We rewrite this term, y is 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on and so forth till x raised to n by n factorial. This can be written as 1 plus x square by 2 into 1 plus x cube by 3 into 2 factorial so on and so forth till n times x raised to n minus 1 upon n into n minus 1 factorial. Now we differentiate it with respect to x. We get dy by dx is, this is differentiation of 1 is 0 plus this is 1 plus 2 times x upon 2 plus 3 times x square divided by 3 into 2 factorial plus 4 times x cube by 4 into 3 factorial so on and so forth till So this is n times x raised to n minus 1 divided by n into n minus 1 factorial. So these terms get cancelled. We get dy by dx is 1 plus x square by 2 factorial plus x cube by 3 factorial, so on and so forth till x raised to n minus 1 upon n minus 1 factorial. So we are missing one term, which is x raised to n by n factorial. So we'll add this term to both sides. So we get dy by dx plus x raised to n by n factorial is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial till x raised to n minus 1 upon n minus 1 factorial plus x raised to n upon x raised to n upon n factorial. Now this term can be rewritten as y. So this is dy by dx plus x raised to n upon n factorial is equal to y. So therefore dy by dx is y minus x raised to n upon n factorial, which is option C. If y is a sin x plus b cos x, then the value of y raised to y square plus dy by dx the whole square is, options are function of x, function of y, function of x and y, d constant. So first we evaluate each term. So we have y is equal to a sin x plus b cos x. Square both sides, we get y square equals a sin x plus b cos x the whole square, which is a square sin square x plus b square cos square x plus 2ab sin x cos x. Let this be equation 1. Now we differentiate y with respect to x. So dy by dx, let this be y dash, is differentiation of sin x is cos x. So a cos x, differentiation of cos x is minus sin x. So minus b sin x. Now we square this term, we get y dash square, which is equal to a cos x minus b sin x the whole square, which is equal to a square cos square x plus b square sin square x minus 2ab sin x cos x. Let this be equation 2. Now we are supposed to find the value of y square plus y dash square. So we add equation 1 and 2, we get y square plus y dash square is equal to a square sin square x plus b square cos square x plus 2ab sin x cos x plus a square cos square x plus b square sin square x minus 2ab sin x cos x. This term gets cancelled. So we have, now we take these two terms common. We take a square common in this term. We get a square times sin square x plus cos square x. Similarly, we take b square common. We get b square sin square x plus cos square x. Now sin square x plus cos square x is 1. We get y square plus y dash square is a square plus b square. So this is a constant term. So the answer is D constant. F of x equal to root of ax plus a square by root of x. Then the value of f dash of a is a minus 1, b1, c0, dA. First we write f of x is root of ax plus a square by root of x. So we differentiate with respect to x. F dash of x is, so differentiation of root x is 1 by 2 root x. So root of a is common. So root a by 2 root x plus a square by root a. Derivative of 1 by root x is minus half times x raised to minus 3 by 2. This can be simplified as minus root a by 2 root x minus a square by 2 root a x raised to minus 3 by 2. This is f dash of x. Now we have to find f dash of a. So we substitute x equals a. So we get root a upon 2 root a minus a square upon 2 root a into a raised to minus 3 by 2. So this is half, and this also this gives us a square by 2a square. We simplify this expression. So a square gets cancelled. We are left with half minus half, which is equal to 0, which is option C. Y is equal to a plus b x raised to 3 by 2 by x raised to 5 by 4, and y for at y dash equals 0, x is 5. So the ratio of a is to b is equal to, the options are root 5 is to 1, 5 is to 2, 3 is to 5, and 1 is to 2. So y dash is, this is in the form of u by v. So derivative of v into derivative of v into derivative of u, that is so this is x raised to 5 by 4 into derivative of numerator is 3 by 2 into b into x raised to half minus v u into derivative of v. So that is a plus b x raised to 3 by 2 into derivative of x raised to 5 by 4 is 5 by 4 into x raised to 3 by 4 divided by x raised to 5 by 4 square. So this is 3 by 2 bx, 5 by 4 plus half is 7 by 4. So bx raised to 7 by 4 minus 5 by 4 times a plus bx raised to 3 by 2 into x raised to 1 by 4 divided by 5 by 4 into 2 is 5 by 2. So this is x raised to 5 by 2. So for y dash equals 0, x is 5. So we substitute the values in this expression. We get 0 equals first we simplify the value of x, then we substitute the value. So we have 3 by 2 b x raised to 7 by 4 minus 5 by 4 a plus b x raised to 3 by 2 into x raised to 1 by 4. Divide throughout by 1 by 4, x raised to 1 by 4. We get 3 by 2 b x raised to 6 by 4 minus 5 by 4 a plus b x raised to 3 by 2. This is nothing but 3 by 2 b x raised to 3 by 2 minus 5 by 4 a plus b x raised to 3 by 2. Now multiplying throughout by 4, we get 3 into 4 by 2, which is 6. 6b x raised to 3 by 2 minus, we expand this term, we get minus 5a minus 5b x raised to 3 by 2, which is equal to 0. So this gets cancelled. We are left with 0 equals b x raised to 3 by 2 minus 5a. That is, now we substitute the value. We get 5a equals b x raised to 3 by 2, which is b times 5 raised to 3 by 2. That is, a by b is 5 raised to 3 by 2 by 5. So this is 5 times root 5 divided by 5, which is root 5 is to 1, which is option A. If y is x times cos x by 2 plus sin x by 2 into cos x by 2 minus sin of x by 2 plus sin x plus 1 by 2 root x, then dy by dx is, so first we simplify the expression of y, that is f of x. So we get, so this is in the form of a plus b, a minus b. So you can rewrite this as cos square x by 2 minus sin square x by 2 plus sin x plus 1 by 2 root x. So this is cos square x minus sin square x is cos 2x. That is for in case of half angle it is cos x. So x times cos x plus sin x plus 1 by 2 root x is our y. So we differentiate it with respect to y. So dy by dx is x cos x, differentiation of x cos x plus x sin x plus differentiation of 1 by 2 root x is minus 1 by 2 into 1 by 2 into x raised to minus 3 by 2. So differentiation of this is in the form of u into v. So this is u into derivative of v, that is minus sin x, plus v into derivative of u, that is 1 plus u into derivative of v, that is cos x, plus v into derivative of u, that is 1, minus 1 by 4 x raised to minus 3 by 2. So this is minus x sin x plus cos x plus x cos x plus sin x minus 1 by 4. This can be written as x raised to minus 3 by 2 can be written as 1 by x root x, that is x root x, 1 by 4 times x root x. Now we take sin x and cos x common. We get sin x times 1 minus x plus cos x times 1 plus x minus 1 by 4x root x. So we find the answer within the options. So we have cos x into 1 plus x, which can be either a or c, 1 minus x into sin x. So the answer is option A, 1 plus x cos x into 1 minus x into sin x minus 1 by 4x root x. F of x is cos x, cos 2x, cos 4x, cos 8x and cos 16x. Then the value of f dash of pi by 4 is, these are the options. So first we divide and multiply by sin x. So we get the form of 2 sin x cos x. So this is f of x equals 2 sin x cos x cos 2x cos 4x into cos 8x into cos 16x divided by 2 sin x. So this is sin 2x, this is sin 2x, 2 sin x cos x. So sin 2x cos 2x into cos 4x into cos 8x into cos 16x divided by 2 sin x. Again this can be written as sin of 4x by 2 into 2 sin x into cos 4x into cos 8x plus cos 16x. Continuing this process, we finally get sin 32x divided by 2 raised to 5 sin x, which is f of x. Now we differentiate with respect to x. So this is in the form of u by v. So we apply the formula of f dash of x is v into derivative of u, 1 by 2 raised to 5 is 32. So v into derivative of u, v into derivative of sin 32x is cos 32x minus u sin 32x into derivative of v, that is cos x, divided by sin square x. So now we substitute the value of x, which is pi by 4. So f dash of pi by 4 is 1 by 32 sin pi by 4 is 1 by root 2. Sin 32 times 1 pi by 4 is again 1 by root 2 minus, again these terms are 1 by root 2, so this is 1 by root 2 into 1 by root 2 divided by sin square x is sin square pi by 4. This is 1 by 32 there's a correction here. Cos of 32 times pi by 4 is 4 gets cancelled, so we have cos of 9 pi, so this is 1, and in this case it is cos of sine of 32 times pi by 4, which is sine of 9 pi, which is 0. So we have here 1 by root 2 times 1 minus 1 by root 2 times 0 divided by 1 by 2. So this is 1 by 32 1 by root 2 divided by 1 by 2. Another correction is differentiation of sine 32x is 32 times cos 32x. So we have 32 times, and again here we have 32 times. We just have here 32 times. So this is 32 times 1 by root 2 into 1. So this is 32 into 32 into 1 by root 2 divided by 32 divided by half. So this is 2 by root 2, which is equal to root 2, which is option A. Y can be if y is e raised to 2x cos x by x sin x, then find the value of dy by dx. Y can be written as cos x by sin x is cot x, so e raised to 2x by x into cot x. So let this be u, let this be v. So this is in the form of differentiation of u by v. So we have dy by dx is v into derivative of u, that is d by dx of e raised to 2x cot x minus u into derivative of v, that is e raised to 2x cot x, derivative of x is 1, so into 1 divided by x square, that is v square. Now this is in the this is in the form of u into v. So differentiation of u into v is x into u into derivative of v, that is e raised to 2x minus cosec square x plus cot x into differentiation of e raised to 2x is 2 times e raised to 2x divided by minus e raised to 2x into cot x divided by x square. We take e raised to 2x common, so we get this is common for this term, so we have 2 times x, that is 2x minus x so this can be simplified as 2x minus 1 cot x minus x cosec square x divided by x square. 2x e raised to 2x into 2x minus 1 into cot x minus x cosec square x divided by x square, which is option A. If y equals 1 plus x raised to 1 by 4 into 1 plus x raised to half into 1 minus x raised to 1 by 4, then dy by dx is, these are the options. First we simplify this equation. We can rearrange this as 1 plus x raised to 1 by 4 into 1 minus x raised to 1 by 4 into 1 plus x raised to 1 by 2. So this is in the form of a plus b, a minus b. So this can be written as 1 minus x raised to 1 by 4 the whole square into 1 plus x raised to half, that is 1 minus x raised to half into 1 plus x raised to half. Again this is in the form of a plus b, a minus b. So we can rewrite this as y equals 1 minus x raised to 1 by 2 square, that is 1 minus x. So differentiating this with respect to x, we get minus 1. dy by dx is minus 1, which is option B. Y is e raised to 2x plus e raised to minus 2x upon e raised to 2x minus e raised to minus 2x. Then the value of dy by dx is, these are the options. So dy by dx is, this is in the form of u by v. So v into derivative of u is e raised to 2x, 2 times e raised to 2x, e raised to minus 2x is minus 2 times e raised to minus 2x, minus u into derivative of v, that is 2 e raised to 2x plus e raised to minus 2x into derivative of v, that is e raised to 2x is 2 e raised to x, derivative of minus e raised to minus 2x is plus e raised to 2 times e raised to minus 2x divided by v square, that is e raised to 2x minus e raised to minus 2x the whole square, that is e raised to 2x 2 times e raised to 2x minus e raised to minus 2x into e raised to 2x minus e raised to minus 2x minus e raised to 2x 2 times e raised to 2x plus e raised to minus 2x into e raised to 2x plus e raised to minus 2x divided by e raised to 2x minus e raised to minus 2x the whole square. So this can be simplified as e raised to 2x minus e raised to minus 2x square minus e raised to 2x plus e raised to minus 2x the whole square divided by e raised to 2x minus e raised to minus 2x the whole square. Rewrite this as 2 into a minus b the whole square can be written as a square minus a square plus b square minus 2ab. So this is e raised to 4x plus e raised to minus 4x minus 2 times e raised to 2x into e raised to minus 2x is 1, since they are reciprocals. Similarly, this is e raised to 2x plus e raised to minus 4x, e raised to 4x plus e raised to minus 4x plus 2 times e raised to 2x into e raised to minus 2x, which is 1, divided by e raised to 2x minus e raised to minus 2x raised to 2. So this is 2 times, this gets cancelled, so we have 2 into minus 2 upon e raised to 2x minus e raised to minus 2x square. This is equal to minus 8 upon e raised to 2x minus e raised to minus 2x square, which is option A. We have to find the derivative of e raised to x into log of sine 2x. So this is in the form of u into v. So formula for differentiation of u into v is u into derivative of v, that is d by dx of log of sine 2x plus v derivative of u. So this is e raised to x into derivative of log of sine 2x is 1 by sine 2x into derivative of sine 2x. So this is 2 into cos 2x plus log of sine 2x, derivative of e raised to x is e raised to x, so this is e raised to x. So we take e raised to x common, so e raised to x into cos 2x upon sine 2x is cot 2x, so this is 2 cot 2x plus log of sine 2x, which is option A. if 2 raised to x plus 2 raised to y is 2 raised to x plus y, then the value of dy by dx at x equals y equals 1 is, the options are 0, -1, 1 and 2. So 2 raised to, now x plus y, differentiation of x plus y with respect to x is 1 plus dy by dx. So 2 raised to x plus 2 raised to y is what is given, 2 raised to x plus y. We differentiate throughout with respect to x. So we have this is in the form of a raised to x. So it is 2 raised to x log 2. Similarly, this is 2 raised to y log 2 but multiplied by dy by dx. Similarly, this is 2 raised to x plus y log of 2 into 1 plus dy by dx, since we have to find the derivative of x plus y with respect to x. So this is, now we take we expand the brackets, we get 2 raised to x log 2 plus 2 raised to y log 2 dy by dx is equal to 2 log 2 plus 2 log 2 dy by dx. Log 2 gets cancelled throughout the equation, so we are left with 2 raised to x plus 2 raised to y dy by dx is equal to 1 plus dy by dx into, this is 2 raised to x plus y log 2 gets cancelled, so this is 2 raised to x plus y into 2 raised to x plus y. We take dy by dx to one side, so we have dy by dx into 2 raised to y minus 2 raised to x plus y, and we take this to RHS, so we have 2 raised to x plus y minus 2 raised to x. So that is dy by dx is equal to 2 raised to x plus y minus 2 raised to x upon 2 raised to y minus 2 raised to x plus y. Now x equals y equals 1. We substitute this value, so we get dy by dx is equal to 2 raised to 1 plus 1 minus 2 raised to 1 upon 2 raised to 1 minus 2 raised to 1 plus 1. That is 2 raised to 1 plus 1 is 2 raised to 2, that is 4, minus 2 upon 2 minus 4, that is equal to 2 upon minus 2, which is equal to minus 1. So dy by dx is minus 1, which is option B. If x is y root of 1 minus y square, then dy by dx is, these are the options. So x is y root of 1 minus y square. So we differentiate throughout with respect to x. So differentiation of x with respect to x is 1. This is in the form of u into v. So this is y into derivative of root of 1 minus y square, that is d by dx of 1 minus y square plus u into derivative of v plus v into derivative of u, that is root of 1 minus y square into dy by dx. So this is 1 equals y into derivative of root of 1 minus y square is 1 by 2 root 1 minus y square into minus 2 derivative of y square into dy by dx plus root of 1 minus y square into dy by dx. Now we take dy by dx common, so we have 2 gets cancelled, so this is minus y upon root of 1 minus y square plus root of 1 minus y square. This is 2 into y, so this is y square. We cross multiply, we get dy by dx into minus y square plus root of 1 minus y square, the whole square upon root of 1 minus y square. So that is dy by dx minus y square plus 1 minus y square upon root of 1 minus y square, that is dy by dx 1 minus 2y square upon root of 1 minus y square. So that is dy by dx is equal to minus root of 1 minus y square upon 1 minus 2y square plus, there is no minus, so the answer is dy by dx is root of 1 minus y square upon 1 minus 2y square, which is option C. If x equals 2 cos theta minus cos 2 theta and y equals 2 sin theta minus sin 2 theta, then dy by dx is, these are the options. So first we differentiate x with respect to theta. So dx by d theta is differentiation of cos theta is minus sin theta. So this is minus 2 sin theta. Similarly for this it is minus 2 sin 2 theta. We take 2 common, so this is minus 2 sin theta plus sin 2 theta. Let this be equation 1. Similarly, dy by d theta is 2 cos theta minus 2 cos 2 theta. Let this be equation 2. Now dy by dx is dy by d theta upon dx by d theta, which is equal to 2 times cos theta minus cos 2 theta upon 2 times minus 2 times sin theta plus sin 2 theta. So this is equal, there's a correction here. A differentiation of minus cos 2 theta is minus of minus sin 2 theta 2 sin 2 theta, which gives us plus 2 sin 2 theta. So this is minus and this is plus here. So we have minus here. So continuing, we have dy by dx equals cos theta minus cos 2 theta upon sin 2, taking minus sign inside, so we have sin 2 theta minus sin theta. Now cos theta minus cos 2 theta, this is in the form of cos of a minus cos of b. So this can be simplified as 2 sin 3 theta by 2 into sin theta. Similarly, this is in the form of sin a minus sin b. So this is 2 cos 3 theta by 2 into sin theta. So sin theta gets cancelled, 2 gets cancelled. So we are left with sin upon cos is tan theta. So tan of 3 theta by 2. So this is dy by dx. So C is the final answer. If y is a raised to x, b raised to 2x minus 1, then double derivative of y with respect to x is, these are the options. So first we have y equals a raised to x, b raised to 2x minus 1. This is in the form of a raised to x. Similarly, it is also in the form of u into v. So dy by dx is the derivative of u into v, that is u into derivative of v, that is b raised to 2x minus 1 into log b into derivative of 2x, that is 2. So then b into derivative of u, that is b raised to 2x minus 1 into derivative of u is a raised to x log a. So a raised to x log a. So dy by dx is taking b raised to 2x minus 1 common, along with a raised to x. So a raised to x times b raised to 2x minus 1. So this gives us 2 log b plus log a. But let this be 1. So from 1 we can say dy by dx is y times 2 log b plus log a, since this is y. So again differentiating with respect to x, so we have d square y by d2y by dx square. So this gives us d by dx of y into 2 log b. Let this be equation 2. So 2 log b plus log a. So this is a constant. So 2 log b plus log a into dy by dx. Now dy by dx is this term from equation 2. So we have 2 log b plus log a the whole square into y, double derivative. So by log we can say log of this is log of b square plus log of a the whole square into y, that is y into, now log of a plus log of b is log of a into b, so this is y into log of ab square. This is d2y by dx square. So this is option B, y into log of a into b square. Correction here, this is we forgot the square, so this is the whole square. So the answer is D, y into log of ab square the whole square. Y square is p of x, which is a polynomial of degree 3. Then we have to find the value of, evaluate 2d by dx of y cube into d square d2y by dx square. It is given that the polynomial is of degree 3, which means after derivating it four times we will get a constant. So p triple dash of x is a variable that which of degree 1. Oh, this is a constant. So since this is the polynomial is of degree 3, so first degree will be first derivative will be of degree 2, second will be of degree 1, and third will be of degree 0, that is constant. So none of the term is 0. So first we find derivative of double derivative of y. So y square is p of x. So now we differentiate it with respect to x. We have 2y dy by dx is p dash of x. That is 2 dy by dx equals p dash of x upon y. We differentiate this again. We get 2 double derivative of x double derivative of y into, this is in the form of u by v, so we get y into p double dash of x minus p dash of x into y dash divided by y square. That is, we take this term to LHS, we get 2y square y 2y square d2y by dx square equals y p double dash of x minus p dash of x into y dash. Multiplying throughout by y, we get 2y cube. We multiplied throughout by y so that we could get y cube, which is given in the question, which is what we have to find. So we have y cube and double derivative of y. So y cube into d2y by dx square is equal to y square p double dash of x minus y into y dash into p dash of x. But y dash is half of p dash of x upon y. So y square p double dash of x minus y by 2 into p dash of x upon y. This is y dash. So y gets cancelled. We are left with y square p double dash of x minus p dash of x this is square, so p dash of x the whole square by 2. Now y square is p of x, so we get p of x into p double dash of x minus p of x, p dash of x the whole square by 2. This is 2 times y cube into d2y by dx square. So now we differentiate this again to get this term. So differentiating this again with respect to x, so we get 2 times d by dx y cube d2y by dx square is equal to p dash of x, p double dash of x plus p of x into p triple dash of x minus p dash of x into p double dash of x, simplifying this term, the differentiation. So finally we get p of x into p triple dash of x, which is option C. Root of y is cos inverse of x, and it satisfies the differential equation 1 minus x square into d2y by dx square minus x into dy by dx equals C, where C is equal to what? The options are 0, 3, 1 and 2. We are supposed to find the value of C. So first we differentiate y with respect to x twice, so we get these values. So root of y is cos inverse of x, that is y is cos inverse of x the whole square. Now we differentiate this with respect to x, so dy by dx is 2 times cos inverse of x. Now differentiation of cos inverse of x is minus 1 upon root of 1 minus x square. So let this be equation 1. We differentiate this again, so d2y by dx square is equal to minus 2. This is in the form of u by v. So v into derivative of u, that is v into derivative of u, so 1 minus x square, this is the derivative of minus cos inverse of x, so this is minus 1 upon root of 1 minus x square. This is the derivative of cos inverse of x, and this is the denominator, which is v. So v into derivative of u minus u into derivative of v, which is cos inverse of x upon derivative of root of 1 minus x square is two x upon root of 1 minus x square divided by root of 1 minus x square the whole square. So this term can be simplified as dy by dx is equal to, taking 2 inside the bracket, so we get 2 minus 2x cos inverse of x upon root of 1 minus x square upon 1 minus x square, that is 2 plus cos inverse of x is root y, and also this term excluding x, 2 cos inverse of x upon root of 1 minus x square is dy by dx, that is from 1. So we can write this as x times dy by dx upon 1 minus x square. This is d2y by dx square. So therefore, taking this term to LHS, we get 1 minus x square d2y by dx square minus, shifting this to LHS, so minus x dy by dx is equal to 2. So comparing this with the given equation, we can say C is equal to 2. So the option is D is 2. We have to find the derivative of tan inverse of cos x upon 1 plus sin x. So d by dx of tan inverse of cos x can be written as cos square x by 2 minus sin square x by 2, and 1 can be written as cos square x by 2 plus sin square x by 2, Similarly, this can be written as 2 sin x by 2 cos x by 2. So d by dx of tan inverse of, so dividing throughout by, okay, we can write this as cos x by 2 plus sin x by 2 into cos x by 2 minus sin x by 2, since this is in the form of a plus b a minus b. Similarly, this can be written as cos x by 2 plus sin x by 2 the whole square. So this gets cancelled. We are left with d by dx of tan inverse of cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2. So divide throughout by cos x by 2, we get tan inverse of 1 minus tan x by 2 upon 1 plus tan x by 2. But so this is the formula for tan of pi by 4 minus x by 2. So this is tan inverse of tan of pi by 4 minus x by 2. So tan inverse of tan of pi by 4 minus x by 2 is pi by 4 minus x by 2. So we are left with d by dx of pi by 4 minus x by 2. So first term is a constant, so it is 0, and derivative of minus x by 2 is minus half. So dy by dx is minus half. If x is a sin theta, y is b cos theta, then double derivative of y with respect to x at theta equals pi by 4 is given by, these are the options. So first we derivate x and y with respect to theta. So dx by d theta is derivative of a sin theta is a cos theta, and dy by d theta is derivative of cos theta is minus sin theta. So this is minus b sin theta. So now dy by dx is given by dy by d theta upon dx by d theta. So this is minus b sin theta upon a cos theta. So dy by dx is minus b by a tan theta. Let this be 1. So again, differentiating y with respect to x. So this is d2y by dx square minus b by a, derivative of tan theta is sec square theta. So sec square theta, since we are differentiating that variable theta, so we multiply it with d theta by dx. So now d theta by dx is inverse of dx by d theta. So minus b by a sec square theta into 1 upon a cos theta is d theta by dx. So this is minus b by a square. So 1 by cos theta is sec theta. So this term becomes sec cube theta, d2y by dx cube. So now putting theta equals pi by 4, we get b by minus b by a square sec cube pi by 4. So that is equal to minus b by a square root 2 cube. So this is minus 2 root 2 b by a cube, which is option A. Which is option A. This is a square. Derivative of e raised to x into log of 1 plus x square is, these are the options. So this is in the form of u into v. So let this be y. So dy by dx is u into derivative of v, that is e raised to x into derivative of 1 plus x, log of 1 plus x square is 1 upon 1 plus x square into derivative of x square, that is 2x, plus v into derivative of u, that is log of 1 plus x square into derivative of e raised to x is e raised to x. Taking e raised to x common, so we get log of 1 plus x square plus 2x upon 1 plus x square, which is
Yeah, what?
option A.